Hello and welcome. In this video I'm going to complete a series of tasks regarding BGP on OcNOS devices. Specifically I'm going to work on AS300. Now what I'm trying to do here is to have a BGP free core on R17 and R18, but I still want to have connectivity from AS400 to 200 through AS300. And for this task I don't really need to have these routers on, so I can just turn them off so that I have less pressure on the server which is running. Of course OcNOS devices are not so heavy, but again that would be a good idea because I don't really want to have these, and also this is going to guarantee that every traffic is going to go through AS300 in the end to reach to AS200 and vice versa. So let's check the tasks here. The task says that configure IBGP session between R15 and R16. I'm going to do that in a second using loopback as the update source. You are not allowed to configure BGP on core nodes, which are going to be 17 and 18 here. mpls and LDP should be configured, and every edge router should have end-to-end connectivity from loopback to loopback for of the other router. That's okay. And finally I'm going to advertise each router's loopback IPv4 address into BGP. I have already done this part, so this is going to be redundant. But let's just do this using mpls. So I'm going to zoom in a little bit here so that you can see this better. And that is my overall lab in here. Configuring mpls, of course, is going to have its own series of videos, and I'm going to speak about them in detail. But here I'm just going to go with very simple type of configuration on routers. So let's first of all start with BGP on R15 and R16. Oh, we already have OSPF here. So from R15 to R16, if I just check here on here and say show IP route, you can see that I have only BGP set here. Let me just see if I have OSPF. So show IP protocol. It says that no, I don't have OSPF, so that would be super easy. I'm just going to say router OSPF 1, and I'm going to have router ID of 15, 15, 15, 15, and I'm going to be super simple. So I'm going to say network 0000, 0000. It should be in area 0. And what I'm trying to do here is to say that Ethernet 0 is going to be passive interface. So I would say passive interface ETH 0, and I'm going to enable that, and then I'm going to commit the configuration. So it says that use clear IPOSPF process. That's okay. So I'm going to do this here, and let's do WR. Okay, now the BGP connection is going to be like this, router BGP, and the autonomous system that we are working in is AS300. So I would say under this, I'm going to say neighbor 16, 16, 16, 16 is in remote AS300, and it is going to use update source of 15, 15, 15, 15. And again, I can just say loopback, but the reason that I'm saying 15, 15 is my loopback can have multiple addresses, and I don't really want to have a random IP address in here. So I just go with a specific address here. Now, the other neighbor, of course, which is an eBGP neighbor, is already configured. I don't have anything to do with that. So what I'm going to do is to say address family IPv4 unicast. And under this, I'm going to say this network, this neighbor should be activated. And that's it. And now I'm going to say commit. Show run router BGP is going to tell me what I have in here. You can see that I already have advertised this into BGP table. So for now, that's okay. So if I just say show IP route, it says that yes, I know about I should know about 16, but I guess on 16 I have not configured OSPF. That's okay. I can just go to router 16 and say show IP protocol. That's totally true. So I'm going to say configure terminal router OSPF1, router ID is going to be 16, 16, 16, 16. And then I'm going to say network 0000, 0000, area 0. This is a super simple configuration just to make sure that OSPF is running, and Ethernet 3 should be passive. So I'm going to say passive interface ETH3 and enable, of course, in the end, and commit and do clear IP OSPF process, and that's it, and WR. And of course I needed to go back to router BGP 300. The eBGP neighbor is already configured, so what I'm trying to do is to say neighbor 15, 15, 15, 15 is in remote AS 300, and also update source is going to be 16, 16, 16, 16. Again, I'm trying to be very specific. So address family IPv4 unicast, and under this I need to say activate. And if I commit and say show run router BGP, then you would see that I have already advertised this network into BGP. So that would be almost everything that for now for BGP I'm going to do. So if I say show IP route, I have this routing information here. So let me see, show IP OSPF neighbor says that for now I don't have any OSPF neighbor. Let me see what the problem might be, because this should say that everything is fixed and working. So some IP addresses are not assigned. That's okay. I can just assign this IP address. It's super fast. So Ethernet 1 goes to 17. So I'm going to say interface ETH1. On here, interface ETH1. IP address is going to be 10, 16, 17, 16/24. And ETH2, let me see, just to make sure, goes to 18. So that would be this 18, and commit, and let's see, show run interface loopback says that everything is configured. Now if I say show IP route, everything seems to be good and okay. So I have received some routes from BGP, from AS200, some OSPF routes from my internal network, and everything seems to be good. So the next step is to check whether I have BGP connectivity between my iBGP neighbors, which I do, and everything seems to be good again. So let me just say terminal width is 256 so that I can see everything in full width without any extra lines. Now that I have done this, let's just go back to here and see some of the stuff that I'm going to do here. The first thing, there are multiple steps that I need to take in configuring mpls in per request. First of all, I should go with all these interfaces, everything that is inside this boundary. These should have LDP enabled on them, and also label switching enabled on them. Now label switching is mpls, so I need to enable them under the interfaces, and LDP label of course is going to be assigned to each one of these interfaces that I have here. Okay, this part is done. Here I need to have the interface under VRF. So, and the same thing goes here. This interface should go under VRF. And like I said, I'm not going to speak a lot about this because I'm going to speak about this in detail in mpls part of the course. But here you should know that because this is going to be my customer, I'm going to assign a specific VRF to that, and maybe an interface or a sub interface to my customer. And after that, customer routes are going to be isolated inside my network, can get to the other side, and the traffic of course is going to be isolated. So this is what the virtual routing and forwarding means in this context. So inside we are going to have mpls, outside we are going to have vrf, and finally, because we have configured BGP adjacency in here, what I'm going to make sure is there is something like a BGP VPN v4 tunnel between these two routers, and that VPN v4 tunnel guarantees that my network is going to be BGP free inside the core. So router 17 and 18 do not have any idea about VRFs. They do not have any idea about this BGP connection. All they do is they're going to create some labels for the internal network, and then they are going to use these labels just to send the traffic from one side to the other side. So we are going to check this and do the configuration step by step. So let's start with the mpls LDP configuration. Now let's go back to the routers and enable LDP on each one of these interfaces that I have enabled label switching. So here on router 15, so I have Ethernet 1, for example, and for this I need to say enable, and you can see that there are multiple options here. So what I'm trying to do is to say enable LDP, and for enable LDP I'm going to use IPv4. Okay, and the next thing is going to be Ethernet 2. I'm going to do the same thing here, and after that I need to assign an IPv4 for the transport of LDP. That would be my loopback IP address that I have on each one of these routers. So I need to say router LDP, and under router LDP these are the commands that you can see, but the most important one of course is going to be this transport address, which is in the end. And I'm going to say that is going to be 15, 15, 15, 15, and transport address of course should be, let me see, transport IPv4 actually, and after that I should say 15, 15, 15, 15, and after that I can just hit enter, and that's it. Now I'm going to commit the configuration, no problem in here. So let's go to R16 and do the same thing here. Interface ETH1. I'm going to say enable LDP IPv4 under Ethernet 2, the same thing. And I'm going to say router LDP transport address IPv4 is going to be 16, 16, 16, 16. Hit enter and commit the configuration. Okay, so let's go to router 17 and do the same thing here. And after that I'm going to have some verifications here. So I have some configuration here, so which is not committed. So let's see what configuration could be. So if I just say show transaction current, it says that Ethernet 0, I guess Ethernet 2 is going to be the problem. So I'm going to say abort transaction, and I'm just going to skip this Ethernet 2, just Ethernet 0 and Ethernet 0, and I'm just going to go with Ethernet 1 and Ethernet 2 because Ethernet 0 might be the problem. So if I say commit, now I have no problem. So I'm going to say interface ETH1. I'm going to say enable LDP IPv4 for ETH2, the same thing, and router LDP I'm going to say transport address is going to be 17, 17, 17, 17. IPv4 of course. IPv4. That's it. Commit the configuration. And finally router 18, which I have to log in again through that. Go to configuration mode, and the same thing is going to happen. Interface, let me just show run interface ETH1 and ETH2. Okay, interface ETH1, enable LDP IPv4, and it to the same thing, and rather LDP, I'm going to say transport address IPv4 is going to be 18.18.18.18. Okay, so let's commit the configuration. So far LDP is created. I'm going to say end. Show LDP, and after that, one of the things that I'm going to check is, first of all, interfaces, and the other one, sessions. So LDP interface says that I have Ethernet 1 and 2 enabled. And what about the session? LDP session says that I am in adjacency with 15 and 16. So I have almost everything that I want to have. And finally, I'm just going to say LDP routes and statistics. So you can see that I have these routes for LDP received from different protocols, connected and OSPF, of course. And finally, statistics, of course, is going to give me a list of options and everything that we have had so far. For example, the number of sessions, hello messages, and everything like that. So if I say show mpls, and after mpls, what I'm trying to show you is the interface. So it says that each one of these interfaces, for example, Ethernet 1, label switch is enabled, minimum label value and maximum label value means that what are the labels that we are going to create. For example, I'm not going to have label 1, 2, 3. Some of them are by default there. The minimum label value is going to be 16 and the maximum is going to be something like that. I can just set this to the values that I want to have, and some more information about these. So I'm going to say show mpls, and after mpls this time I'm going to say LDP, and after that you can have neighbors, which is going to give me some lists of neighbors for mpls LDP. And that's almost everything that I want to see here. Okay, let's continue with the rest of the configuration. That's going to be a little lengthy for this video, so I'm going to stop this video right here and continue in the next video so that we can just configure VRFs and after that VPN v4 address families.